So in this lesson, I'm going to further explain how to classify matter, both into pure substances and mixtures, and then into elements, compounds, homogeneous and heterogeneous mixtures. Okay? So if you have matter that is made up of only one type of atom, then you have what we call a pure substance. Okay? And pure substances can be broken down into two different types. Okay? So if you have a pure substance that has only one kind of atom, then you have what's called an element. Okay? And the way that you know it's an element, it's going to only have one or two letters. Okay? If it's one letter, for example, oxygen, that letter is capitalized. If you have two letters, then the first letter is always going to be capitalized, while the second letter is going to be lowercase. So in the example here, you see copper, right? Copper has a chemical formula of Cu. The C is capitalized, the U is lowercase, okay? Now, a compound is a different type of pure substance that contains two or more different elements that are chemically combined. And we see that in the form of chemical bonds. The elements always combine in what we call definite proportions. So what exactly does that mean? Well, let's look at the example that we have here. So we have sugar. The chemical formula for sugar, table sugar, is C12, H22O11. Okay? So we've got three different types of atoms. We've got 12 carbons, 22 hydrogens, and 11 oxygens. In order for it to be sugar, it has to have that same ratio of carbon to hydrogen to oxygen always. As soon as you change one carbon or one hydrogen or one oxygen, you will no longer have sugar. So that's what I mean by definite proportions. Okay? So those are pure substances. Okay? Pure substance, only one type of atom or molecule. If you have just one type of atom, it's an element. If you have more than one type of atom that is chemically bound, it is a compound. Now let's talk about mixtures. So a mixture is made up of two or more substances that are physically combined. So they're mixed together. They are not chemically bound to each other. They don't form bonds. So you can see in this diagram here, we've got two different examples. We've got tea here, and then we've got oil and water. So notice here that unlike with the sugar, where you see all of the atoms are chemically bound together, here you've got a molecule here, a different molecule here that is not chemically bound to it. They're not attached to each other. And so that's what makes it a mixture. Same thing with the oil and water. Here's an oil molecule, and it is not chemically bound to the water. So that's why it's a mixture. It's physically combined. All right, a mixture that is uniformly mixed is called homogeneous. And a special name for this that we say that it is a solution. So you use solutions in your everyday lives. If you've ever drunk soda, that was a solution. And that's because, just like you can see with this tea here, everything is evenly mixed throughout. Better said, if I were going to go to a movie theater and it was dark, if I feel comfortable consuming that beverage or that food, knowing I'm going to get the same thing every single time because it is uniformly mixed, then I know I have a homogeneous mixture. So for example, tea, soda, ice cream. Okay? If I have vanilla ice cream, I'm okay eating that in a theater because I know I'm going to get the same thing every single time. However, if you have a heterogeneous mixture, it is not mixed uniformly. So the example that's given here is water and oil. So notice they're not mixed evenly because you've got two separate layers. You've got a layer of oil and you've got a layer of water. Other real-world examples of heterogeneous mixtures. If I'm talking about ice cream, right? We said vanilla is going to be homogeneous, Rocky Road is heterogeneous. I would not feel comfortable eating that in a movie theater. I might get some nuts at one point. I might get some pieces of chocolate. I might get just straight ice cream. I might get marshmallows. Who knows what you're going to get? So homogeneous, it is evenly distributed. Heterogeneous, it is not. Okay? So let's look at some examples to really make sure we understand the difference. So the first step we always take is deciding whether or not we have a pure substance or a mixture. If you've only got one kind of atom or molecule, you have a pure substance. If you've got multiple that are mixed physically together, they're physically combined, then you have a mixture. If I've decided it's a pure substance, then if I just have one type of atom, it's an element. If I have multiple, more than one different type of atom that are chemically combined, I have a compound. Homogeneous mixture occurs when I have a mixture that is uniformly mixed. Heterogeneous is when it is not uniformly mixed. So let's look at these 4 examples. A chocolate chip cookie. Okay? So for a chocolate chip cookie, I've got a number of different components to that. I've got sugar, I've got water, I've got flour, I've got butter, which consists of a number of different molecules in and of itself. So I know that this is going to be a mixture. It is not a pure substance. Okay? Well, what type of mixture is it? Well, if I have a chocolate chip cookie, is it uniformly mixed? And the answer is no, because you have chocolate chips floating around in the cookie. You don't know what you're going to get each bite. I would feel uncomfortable eating it in a movie theater. So it's heterogeneous. Let's look at the next example, salt, NaCl. Now notice, as we had noted earlier, by putting these elements right next to each other without a space, we are noting that they are chemically bound together. So here I have just one type of molecule, so this is going to be a pure substance. But because I have 2 or more different atoms, it's going to be a compound. The next one, graphite. That's what you're using right now to write these notes. That's a type of carbon. Okay? So graphite, it's just in one element or one atom, so it's going to be a pure substance. And because it is only one atom, carbon, it's going to be an element. Here's the last one, and this one really trips people up a lot. Tap water. When we're discussing water, water has the formula H2O, which would make you think that this is going to be a pure substance and a molecule because you've got 2 different types of atoms. However, the water you get from your tap is not just H2O. It has a number of different components in it. So some of the chemicals that you'll find in tap water, chlorine, right, which is to purify the water, fluoride to help prevent tooth decay. I'm not going to get into all of them, but there are a lot of different things that will be found in your tap water. And so as a result, it is not going to be a pure substance. It is actually going to be a mixture. However, because it is uniformly mixed, you're going to get the same thing every single time. It is going to be a homogeneous mixture. Okay? If your tap water is not homogeneous, please don't drink it. There's something wrong with it.